Hi there, welcome back to First Principles. Today we've got Baval with us and we'll be speaking about data science. How are you doing, Baval?
I'm doing well, Sagar. Thank you so much for this podcast. I mean, I'm really excited. I'm feeling really great,
So am
and
I, so am I.
great. Good to know that. Yep.
Okay.
So, yeah.
Tell me something before we begin, delve into the topic. Just for the context of this episode, could you introduce yourself to audiences?
Yeah, sure. So, I mean, I'm working as a consultant data scientist and AML engineer. So my background is basically in data science domain only.
Hmm.
I've worked in past on different data science related roles like data scientist, AML engineer, consultant, research assistant, analyst. So those kind of roles I have been into. And so far, it's been a very amazing journey. I'm really enjoying this domain, and it's really fascinating because every time we have new problem to solve upon, new challenges, new skills. So it's really good.
Okay. I want to ask you, like, we'll basically touch upon the basics of data science, start off from where it started. But before that, tell me, how did you get interested in it? Because to the best of my knowledge, you went to university in an engineering discipline, right? So data science is slightly different. Is that true?
Hmm.
Okay.
Yes, definitely. So when I was in my bachelor's at that point of time, there was not that much hype of data science.
Hmm.
So in when as far as I remember, in my third year, it was that we got some guest lectures from professors from different universities across the globe, where we were introduced to these kind of topics because the curriculum which I studied in my bachelor's was not having explicitly these subjects,
Hmm.
but they were being taught in between other subjects.
Hmm.
So when we got to know about these things, they seem very fascinated. The very first thing is because they were different, and there were not many folks behind them because most of my class was targeting either the Infosys or TCS based upon the software development roles,
Yeah.
tester, and all those things which are very common and which are coming from many years, right? And very few, even I can count them on numbers, like 3 to 4 students were there who are just, want to explore this domain.
Hmm.
So that thing which keep you separate from others, and apart from that, something new which you can, learn about that part. That actually brings the curiosity under me, like so that I can actually look about what this domain actually carries and what we have to do in order to get into this domain. So from there, this all began.
Okay. All right. Well, okay. So that's interesting. In third year, you got really fascinated by the subject. Now, is data science an engineering discipline? Is it like the physical sciences, like physics, chemistry? What is like what's the closest thing? Is it math? Is maths the closest thing to data science?
Yes, so majorly, if you look into the traditional machine learning, right? So that is all about the algorithms, the
Hmm.
statistics, the probability, all those things. But as we come to this, the deep learning part, right?
Hmm.
So that deep learning thing comprises of all other things as well. So
Hmm.
how efficient you write the code, how we can actually automate the process, how you can speed up the things and take them to the level where they can start thinking upon their own, right? So if we go back into the history of this thing, so when we look into the history, we see that there was initial introduction of neural networks, but it wasn't that famous because we were not able to capture the non-linearity, means complex patterns out of the data.
Hmm.
We can only map like, okay, if x is the input and y will be the output, and if there is a scalar multiplication with that number. So mapping those easier problems and looking into the linear regression kind of things at that point of time. But once this back propagation came, the whole journey starts changing, and we basically say that after year 2000, it's an era of deep learning. Like with every year we got new models and everything. Basically the main aim was to mimic the human brain.
Hmm.
So that was the main idea around which these algorithms start building upon. And now with time, till 2024, we can say like, yes, we have attained some success in that domain. Not that much, but yes, some significant success.
So you said you've used a lot of terms here, so I'll have to double click on some of those because they're not very clear to me. But let's just start with the basics. You said the main aim was to mimic the human brain. In what
Hmm.
respects? In which human brain are we trying to mimic? In the sense of what, like, I don't think with data science you can still do the dishes or something like that. You might be able to if you put it in some kind of a robot, I hear. But what capability are we mimicking?
So when we talk about the human brain, we talk about the neurons, how they process the signals, how the human brain thinks, reasoning capability, basically, right? So
Mm-hmm.
that is what we are trying to build upon, and it's generally being said that we are trying to build the artificial brain. So when we talk about these terms, machine learning, deep learning. So basically, deep learning is nothing but training a model. Model is just an artificial neurons, right? Out of which a network is being built up, which is named as neural networks.
Mm.
It's nothing but, in simple terms, if I will say, an artificial brain only.
Okay.
So yeah, we are working upon making that artificial brain that significant that it can take decisions upon its own.
Okay. Okay. Um, let's start with trying to understand this for me with some comparisons, right? So, how is data science different from computer science and statistics? And what else? There's one more thing, right? Machine learning. How is data science different from all these three aspects?
Yes, so you can take data science as a big bucket, right?
Okay.
And if we dive into one step further, we will see the machine learning or the statistics, right?
Okay.
So those are basically the traditional algorithms with which we can prove the algorithms. We can actually tell this thing like why, if particular decision is being made by the algorithm, what was the reason behind that? What were the factors, right? All that can be explained
Hmm.
to some extent, right? So that whole process comes under the machine learning. But when we dive one more step deeper into the deep learning, right, then what happen is inside the neural network, the artificial brain we are saying, right? So I can't say that, Sagar, if you are talking to me, XYZ neuron of your brain is returning this information or talking about that particular thing, right? We
Hmm.
generally say that, okay, this part of the brain or a bunch of neurons are doing this operation and that operation. Similarly, in deep learning, we can't explain the process, how it's taking making those decisions.
Hmm.
But in generally, we can tell, okay, these are the different layers. What are their functions? What are their operations? The way we define the brain, like the left brain, right brain, back of the brain, that manner.
So that's okay. That's fascinating. You can't explain how an output is coming. Hmm. Okay. So how do you put the components together, and then how do you know like they will interact in a good way and give you a proper result?
Yes, so for that part, there are certain. I will use some terms which
Hmm.
actually define like different kind of problems which we solve. Right? If we talk about the supervised learning problems, that means I'm giving some data and also telling that if this data is being given to model in this way, this will be the output. Right?
Hmm.
So we
Hmm.
know the ground truths, and according to that, when we pass it through that artificial brain, we compare what the artificial brain is generating with what the ground truths we are having.
Okay.
So in that way, we actually analyze like how much learning is being getting done over there. And
Okay.
accordingly, the algorithms are improved, the different architectures are coming up, and then different ways to calculate the loss, of course. So all those things.
Okay. Some actually a lot of basic questions over here. Just
Yeah,
walk
sure.
me through what is an algorithm exactly.
So algorithm is just a way to you can say structure the neurons, the artificial neurons.
Okay.
I mean, if let's suppose I say your brain has three sections, right?
Hmm.
Similarly, my artificial brain can have four sections, five sections, 10 sections, and in each section I can have different number of neurons, and these neurons can interact with each other in different capacity. They all can talk to each other, or
Hmm.
we can change the algorithm by saying like this the neurons in this particular layer can only talk to neurons in that layer, right? So we can drop them randomly, the connections basically, and all those things. Like we can actually control how that network will interact.
Right. So you're creating a
Yeah.
network essentially. So that artificial brain is a network of, I know you're saying neurons is a metaphor, but like in the physical layer, what exactly is this network for? Of.
Yeah, so it just passes the input, the way the brain process the input signals, right?
Hmm.
Whichever
Hmm.
body or sensory organs feel and all that stuff. Similarly, the input data passes through that in artificial brain and
Hmm.
accordingly traverse through whole layers, and accordingly an output is generated. The way you can correlate it with our brain, the way the signal is returned back to whatever we understand from the environment.
Okay. And you also mentioned the term efficiency. So what does that mean in this regard?
Hmm. So efficiency means like when we are automating some processes, right? So we said like, okay, just not building something and every time hard coding things.
Hmm.
It should start learning from an example, and whenever that similar kind of a scenario is coming, it should be able to make decisions based upon that.
Okay.
So that way, like, not remembering the data, the term is like not remembering the data but journalizing on the data.
Journalizing on the data, like with a J.
Yes, with the
Uh,
G,
okay, okay,
journalizing.
generalizing. All right, all right,
Yeah,
all right. So,
yeah.
so you said no hard coding, but there must be some level of hard coding which
Yes,
starts it off.
definitely.
Okay.
Exactly. So when we start from some point, it's similar to the way, like, when we teach a child any
Hmm.
language, right?
Hmm.
We tell them basics. We tell them how to form the sentences, but it's not like we always tell them that form this sentence like this only.
Hmm.
Once they learn how to form it, once they learn the basics, then they actually bring their creativity into it.
Okay. Okay.
So that creativity comes with how the neurons are actually being arranged,
Hmm.
how that
Hmm.
artificial brain is being arranged, and whole lot of research is going around it, building different models to obtain different kind of results.
Okay. Is this like how much is this field evolving? Is this like a settled thing, or we still are finding out a lot and it still has a lot of scope to grow? Data science.
I mean, as I said, like, the main aim is to mimic the human brain. So
Hmm.
until or unless we achieve that level, the research won't stop. So there are many aspects to it, many verticals. If we go more deeper into this domain,
Hmm.
so it's really evolving at very fast pace
Are,
nowadays.
are we only trying to mimic the reasoning capability of the human brain, or also the emotional capability and every other thing that the human brain does? Because I don't know if we actually have figured out the whole human brain itself. That's also a project was going on. So, what's the scope?
Yes. No, there are different, parts of it, like, the way we say reinforcement learning,
Hmm.
making the model learn from the environment,
Hmm.
a supervised learning where we just give examples and we have the data which is trained already. Then there is super unsupervised learning. So
Hmm.
all these are heavy terms. I mean, but these are basically the further domains into which we are working, right? Different
Hmm.
models are being released, different architectures are being released depending upon different use cases which we can solve.
Okay. Supervised learning, you said that you set a few ground rules, then you show the machine or whatever, the network a few examples, and then it tends to understand and tends to learn. Like it's essentially figuring out what the correlation is. Is that correct? Is my description
Yeah,
of that
in
correct? Hmm.
naive terms, we can say that because we have the labeled data, right?
Right,
So we know that if let's suppose take an example of a dog cat classifier, very
right,
common example.
right.
If I'm giving my models that data, I'm telling it first that this is a picture of dog, this is
Hmm.
a picture of cat,
Hmm.
and after giving few examples, after training it, I will randomly throw some image and then we'll see like whether it's able to classify it or not, right?
Okay, okay.
So that is kind of an example of a supervised learning.
All right. So a few memes I've seen over the few years where a cookie with chocolate chip cookie has been classified as a dog.
Yeah.
Now that happens. That's true.
Yeah.
Okay.
Yes,
And
that
how do you
happens.
correct for that?
So, in those scenarios, what is happening is when you are giving in a picture of a dog, what
Hmm.
model is learning is the coordinates. At back of the model, everything is mathematics.
Hmm.
Model don't understand the images, they don't understand the textual data. Every input we give to the model is
Hmm.
actually being transformed into numerical representations.
Okay.
So everything is calculation, you can say, right?
Hmm.
So that calculation, when you gave in a picture of a dog or a picture of a cat and you saw that image where they resemble the cookie, so what is happening is the eyes, nose, there is three parts which are highlighted, right? And
Hmm.
similar way in a chocolate chip cookie, three pieces of chocolate are over there.
Yeah.
And when you see that the difference or the distance between the eyes and nose, the coordinates is same as that of cookie, then
Hmm.
obviously model get yeah, somewhere like confused between whether it's a dog, cat, or a cookie.
In that scenario, and of course, I understand you can't go into great technical detail here, but in that scenario, do you introduce more variables, more nuance into the model to distinguish a cookie from a dog?
So in those scenarios, what we do is we generally give more data. We
Hmm.
augment the data basically from different angles, positions, so that model can make better decisions.
Okay. Okay.
Yeah.
And what is unsupervised learning then?
So unsupervised learning is where we actually don't tell the model what data it is. We
Hmm.
just give the data, and then based upon that whole, it we either segregate data into different buckets, you can say,
Hmm.
right? Okay, there is let's suppose we give a whole data of what we can say, let's suppose we have whole pictures of animals, right?
Hmm.
And we just gave all of them to the model. We didn't tell it like whether it's a dog, cat, horse, anything, right? But what model will be doing in those scenarios is it will put them into separate buckets where most of the images of dogs will be under one cluster, most of the images of horses will be in one cluster. So similar things came together,
Hmm.
and the ones which are dissimilar are away from each other. So
Right.
that's a very again a knife kind of an example when we talk about the unsupervised learning. So we try to learn the patterns
Hmm.
inside the data.
Okay. So do you think, let's say in this scenario, if you gave a lot of pictures of dogs and cats and then mechanical dogs or toy dogs, you think it's going to still categorize those toy dogs as dogs here, or it's going to throw out a separate category called, I don't know, artificial dogs?
It depends. It depends upon different algorithms. Maybe the one which were the earlier ones,
Hmm.
they will not able to differentiate between them.
Hmm.
But again, the new algorithms which are coming, and if you are tuning it more and more, right, giving it more data, so it can segregate it depending upon the different parameters. Again, if we go into the details, so we can segregate them as well, but at times they can also get confused between them.
And what is a model again? And I know I'm going back and forth, but that's just for understanding. So how would you define a model? Spend some time over here.
Yes. So again, talking about the same thing, model is nothing but the way, or you can say a black box, which generally is being referred in the books, right?
Hmm.
Which actually makes decision.
Okay.
Now that decision can be simple of an equation as well. Let's
Hmm.
suppose y is equal to mx plus c.
Hmm.
If I say like that's my machine learning model, then that model is just mapping the input to output with those parameters, right?
Yeah.
So as we go more and more into depth, there are more complex structures which are making the decisions.
And is this model okay? Do we have models making models as well, or humans make the models and then everything else is basically done thereafter?
Yes, so before this, the era of Gen AI, right? When we are talking about the large language models and all those things, before that, humans were creating those architectures and models. But now we are at certain stage that if we give certain kind of architectures and ask the model to generate something out of it, they are having that capability to generate it.
So they are
So from
generating a
different
model, a new model.
architectures.
Hmm.
Yes, so that's because that's why they're called the generative models.
Hmm. Hmm.
They
Hmm.
can generate,
Okay.
but we can't guarantee like whatever the things they are generating
Hmm.
are 100% factually true or they are making sense. They do hallucinate, but again, a lot of things are going on now, and if we look into, there is a platform called Hugging Face, right? A lot of models, people or the organizations which are releasing, they are being classified, or you can say tested against certain data sets
Hmm.
and how they're performing. Basically based upon that, a leaderboard is maintained, and you can see from there like, okay, this model is having this much reasonability power, this model is good in mathematics, this model is good in multilingual data, right? So based upon a use case, you can actually pick it from there.
Okay.
So in that way we can say like earlier it wasn't that possible, right, to generate model architectures from model. But now if you give some kind of a raw material,
Hmm.
you can generate the final product out of it if you are giving the instructions very clearly.
Okay. Microsoft for its data centers basically opened up 3 Mile Island over here. And well, I'm glad just because I like nuclear energy, but I'm just wondering
Okay.
why do these models require so much energy? Is it just because it's raw compute power? Is that the reason why?
Definitely, when you are talking about these large language models, so 70 billion, 130 billion, so when you are having that much amount of, or you can say count of parameters, right?
Hmm.
And you are training on humongous data, more than even petabytes.
Hmm.
So you really need more computation power for that.
Okay.
And even these trainings go on for 6 months and even more than years, right? So here the picture of Nvidia comes, right? So where they are releasing these GPUs and all those things. You remember when, I mean, you can tell it better, like when you were in your college days, right? So there were no talks about the GPUs. there were simple laptops we were using,
Yeah.
and there were really different use cases
Yeah.
for the laptops. But now this gaming industry, and this the data science field, that has actually brought up the use of GPU to very common.
Yeah.
And the market is now, people are, even if they don't want to utilize a GPU, still they want to buy it,
Yeah. Yeah.
because
Yeah.
it's becoming more kind of an status symbol kind of a thing nowadays, that yeah, my laptop is that strong, I can
Hmm.
play games with that much graphics. Or if you are not into the games and all that stuff, you are a data science guy and you want to use the models or train them on the local and all those things, so we generally utilize the GPUs.
So GPUs, graphical processing units, they I guess are mimicking CPUs, which is the central processing unit. And I'm assuming that the electronic architecture of those are different. They GPUs came by because of the heavy compute requirement, but also for efficiency because everything you can't just brute
Yes.
force. And that's the reason why Bitcoin miners started using GPUs with their rigs, and now data scientists are doing that. So there are some companies making, I guess, trying to remake chips, reinvent the wheel, because that
Hmm.
needs to be done, because there must be some efficiency when it comes. Like if you want that kind of a capability on every laptop and not be connected to a big data center run by a big company, I guess that's going to be a way forward. So with all of that in mind, what is architecture in this context?
Architecture in with respect to what you're asking, like
Well,
building of GPUs.
with respect to building of GPUs, but also in the other context of like generally just building of models. So just give me the
Yes.
GPUs first. Yeah.
So, um, for the GPUs, how the architecture is being built, that can be more better told by the electronics guy, right?
Okay. Okay.
Those who are working in those domains. But if you talk about like how we actually utilize them,
Hmm.
so when we train the data, right? So there are different ways. Either you can give data to the models, or models are basically utilizing again these GPUs, right? We can use them sequentially. We can do the parallel computing. We can do, right, utilize multiple cores. So with the advancement of these techniques and everything, right, having multiple cores in your the machines, right, we actually expedite the process. So remember, we were talking about the optimization.
Hmm.
So here that thing comes up. The optimization is more when you have a better machine. You can optimize your code, you can run it faster. Even the Google Colab and the platform called Kaggle, they are providing the free GPUs to promote these things, so that we guys, and the community actually learn how to write the code that way, which is more efficient. We
Okay.
shouldn't be relying upon the just old machines and working in same kind of a culture. Now things are changing at very fast pace.
Yeah.
Free GPUs are provided from Google Collabs and in even in the Kaggle, right?
Right. So if the underlying architecture of the GPUs, the substrate changes, I'm assuming that the ways other things are done at the top layer will also change. Or perhaps there's going to be a way for you folks to do whatever you're doing and the middle layer is going to change. Like, what do you see is coming in the future?
So definitely there will be more advancements in these GPUs, right? And the machines, we talk about, fifth generation, seventh generation, ninth generation. There are always some changes. And if you go into the Apple M1 chip, M2 chip, M3 chip, and for a normal human being, when we look into the, those specifications, they just say that more compute time, more better graphics, all those things. So those are only being possible with advancement in these chips which are being made,
Hmm.
right? So again, there is whole lot of scope in improvement in them, as well as if we talk about the models. Because if it's an era of generative AI, right, we are having generative models, then we can do a lot more with them,
Hmm. Hmm.
right? Because earlier it was a generic model when chat gpt came, right?
Okay.
Now what is happening is we are going domain specific. Now chat gpt is specific for financial domain, chat
Hmm.
gpt is specific for taxation, chat gpt is specific for healthcare. Now
Okay.
they are going behind that thing.
All right.
So if I take it a bit back, right? So what was happening is there were models called named entity recognition,
Hmm.
where from the textual data we actually pick the entities based upon our use case. Let's suppose my model is trained upon five entities where I'm picking the quantity, location, place, right? What was happening is earlier there were again similar kind of you can say pattern was observed, that different models of named entity recognition were coming for different domains.
Hmm.
Now, it's time for the generative models, different generative models are coming for different domains, which are trained upon more of that data, or you can say fine tuned upon that data.
Okay.
So, yeah,
Okay. So
that's
you could get weird answers if you basically are asking tax questions to a medical trained model.
yes,
Okay.
yes, yes,
All
yeah.
right. But could we get to a stage where we'll have like an assistant that kind of knows everything about everything? Because that's a very good assistant to have, like in terms of
Yeah,
generative AI. Is that where you're headed?
yes, yes, definitely. With coming few years, and even there are few good examples. GitHub Copilot,
Mhm.
which actually help us to code better.
Okay.
Microsoft is providing that service. So, like that, there are many other models which are, you can take it like this way. When we are training the generalized model, it is
Mm.
actually learning about the basics of a language.
Right.
The way we taught toddlers about A, B, C, D, right? And then we take them into specific domain when they're in their high school, whether they go to the medical, whether they go to the other domains. Similarly, now we have trained the base model, we are fine tuning it, means after giving the whole journal knowledge about that particular data and everything, we are giving them now specific data to particular domain,
Mm.
so that they can actually now become specific to that particular data. So again,
Okay.
there are different ways to do that and everything, but that's where we are now heading towards.
Can you give me the difference between data science specifically and generative artificial intelligence, or like Gen AI? Or is data science like just a big term and Gen AI is part of that?
Yes, so the way we were talking, like, data science, machine learning, getting more specific, deep learning, again, into deep learning, getting into more specific is generative AI.
Okay, so it's nested.
Yes, it's nested.
All right.
Because we are not leaving the other things behind. Even when you're working with the generative AI models and you
Hmm.
want to build some application, you still are making, or you are solving a classification problem
Hmm.
at the end of the day, right?
Hmm.
For many use cases, you are using those models to cater to the needs which are being actually required in order to fulfill the ask, right?
Right.
So it's all interconnected.
It's all interconnected. Okay, so in this scenario now, let me ask you this. My understanding is that you would need data science will get a lot of input from mathematics, statistics, probability, computer science. Obviously, machine learning is part of that, but also linguistics and languages. How important is linguistics in this regard? And just people who understand languages.
Yes, definitely. So, a part of the community is now working upon training these artificial brain different languages.
Okay.
There are companies which are actually needing some good language experts which can evaluate these models during those training phases,
Hmm.
that the models actually understand the semantics very well.
Hmm.
Now, the way the model is understanding the semantics of English is far different than how it will be understanding it for the Punjabi language or German or French.
Hmm.
So there are companies which are hiring those linguistic experts to help them to transform the data, to evaluate the data, to understand basically the data, right, which either is generated by the model or what data is being given to model for the training.
Hmm.
So there is a huge role of those linguistic experts nowadays.
Okay. Somebody who wants to wherever they are, and let's say they are in a non-technical fields or a technical field but a non-computing field, what would you suggest they do in order, like what skill sets should they acquire in order to work in the broadly defined data science industry?
Yes, so it actually, Sagar, depend upon what kind of hat you want to wear,
Okay, what are the
right? So
hats?
there are, yeah, so I mean, here hat is referring to different roles under the data science community, right? You
Okay.
want to go into the data analysis part, you want to go for the data scientist, you want to be an AML engineer, you want to be a data annotator, you want to be data evaluator. So based upon that, the basics you have to cover, right? But again, you must have the whole domain knowledge where you know at least basics of machine learning, statistics, probability. Those are must in order to understand the advanced topics and all those things, and
Okay.
basic coding as well, definitely.
Coding and what's the best language over here?
Majorly the community is using the Python
Okay.
nowadays, and
All right.
it's being now the community is huge now for the Python.
All right. So
Yeah.
Python, coding specifically, do they need theoretical computer science as well, all those efficiency scores and all that, or is it just like programming?
So even if you look into the curriculums nowadays, Sagar, most of the universities are having specific now. You can say bachelors in data science.
Hmm.
Earlier, it was like bachelor in computer science only,
Hmm.
and then from there, either you become a software developer or you go into the data science domain or into any other domain.
Right.
But now they are having specific what we call it the bachelors, right?
Hmm.
So
Hmm.
I'm teaching in one of the university where they have a specific curriculum where they
Hmm.
are just focusing upon first training them about the knowledge of Python, right?
Hmm.
And specific libraries like pandas, numpys. So those are some specific libraries which actually help us to work with the data to do mathematical calculations using
Hmm.
coding.
Hmm.
And after that they just take them to the journey of this artificial intelligence where they learn machine learning first, then deep learning algorithms, then do some projects, internships. So rather than specifically spending time upon learning about the network security, all those other domains under the computer science, they are paying more attention towards those algorithmic part of or you can say the basics which is required to get into the data science,
Okay.
these statistics domain sorry, statistics, probability, and all those things.
Okay. So in maths, it's statistics and probability. And do you need other maths sort of the subdisciplines as well, like linear algebra, or I don't know what else?
Yes, definitely.
Okay.
You do need, yeah, yeah. Because in order to understand those algorithms, the proofs and everything, the derivation, all those stuff, right? You need to be very well versed with these concepts, the
Give me some
mathematics,
more math subdisciplines. So statistics, probability, linear algebra. What
linear
else is
algebra.
required?
Yeah, majorly these three are there.
Okay.
Majorly, yeah,
Okay.
majorly.
And double click on ML for me. So I know ML is like the starting point, and we've spoken a lot about what data science can be and Gen AI can become. What is an ML? How do you define ML? Like scope it out for me. And then how do you learn ML?
Hmm. So, in order to learn machine learning or ML, basically, right, we must be having a basic knowledge of statistics.
Okay.
Because what I'm saying is you generally proceed with linear regression, logistic regression, and we have certain terms like cost function, loss function, right?
Mm,
So if you're having a base of a good statistics, you can actually get more out of that part. It's
mm,
not that if you are not having a knowledge of statistics you can't learn machine learning. It's
mm.
not like that.
Mm.
But it's better to have statistics knowledge beforehand, then you can actually utilize it more, or you can say get more out of it.
Okay. Okay. So I'm just categorizing all of this as applied math, basically, because you don't want to be a total statistician, but you need a certain amount in order to like, throttle away over here.
Mhm.
Okay.
So
Okay.
the statisticians are basically having those defined methods, certain kind of test, t-test, and all those things,
Mm,
or finding the correlations, Pearson correlation, and all those kind of stuff over
mm,
there to actually look into the data and
mm,
analyzing.
mm,
But when you take it one step further, when we go into the deep learning,
mm,
then there is something new which actually comes up, right?
mm,
When
mm.
we start playing with the architecture of neural network. So things start changing over there, but again we are solving the problems like classification and all those things. So the problem generally remains the same, but you can say the way we are approaching it is actually changing.
Okay. Can
Yeah.
you tell me what would wow you if a particular like okay, let me just rephrase that question. What use cases do you as a consumer, not as a producer, would you like to see out there in the world which would really like impress you with Gen AI or data science or anything in this field?
So, I mean, majorly what I feel is like, the redundant work which human do. If that can be automated and that can be taken by the AI, that feels really good because, interacting to some human for the same thing again and again,
Hmm.
I feel like it's more better to have a word with the machine over there
Okay.
when we want to get, same thing done from them. So those things when we saw that are getting replaced by this AI, right? That seems fascinating.
Okay.
And moreover now the automate the driving cars and everything which is coming out, that's really amazing thing. I mean, if we just pay a thought about it and look into how advanced the things are getting now. And let's take in a simple example of when you shift the lane, right? The lane guidance system which we have now in the cars and all those things. So in coming years you will see that there will be more advanced features which will actually make the human's life more secure and safe.
Mm-hmm.
Definitely there are other aspects associated with them. If things go wrong, they can go very wrong, but
Mm.
but actually they are helping,
Right.
they're helping us.
So it's
I
an
mean, I have,
explosion. Go ahead. Go ahead.
yeah, no, so please go ahead, you were
No, I
saying
was saying
something.
it's an explosion of intelligence, and of course we can use more intelligence because we need to solve problems intelligently. And yeah,
Definitely.
and if problems have a set of problems have solved, human bonds are kind of infinite, so new problems will come in. So it's good to have more
Yeah.
intelligence. But then the question is, why so much energy? Because the human brain doesn't require like billions of terawatts of energy, right? Or whatever the number is. It doesn't require big data farms. It's pretty energy efficient in that way. So ultimately, is this like a hardware thing, or are we training it based on some old von Neumann electronics, and that's the reason why it's requiring so much energy? Like I know you might not have like a very good understanding of electronics, but just give me your hypothesis. What's your speculation?
um just I will reiterate what you just said. Just let me know if I'm getting it right. So
Yeah.
you're saying like why we need a lot of energy to actually train these models or preserve that data where we are having these bigger data centers and everything, right?
Because the human brain, I mean, it's trying to replicate the human brain, right? A human brain, I don't know, it's like 40 watts of energy. It's not that much. So why do we need so much energy over
Oh,
there? Yeah.
yeah. So see, it's not just about the way that information is being processed. That's one aspect to it.
Mm.
The other aspect is the data.
The data. Oh,
That's
yes, of
that's
course.
very important, right?
Mm, mm, mm,
I mean, we have to keep it somewhere.
mm.
So different kind of data is having different kind of things associated with it.
Right.
If we are talk about the PII data, personal identification data, that's very important. We need to preserve it. Lot of things to be taken care of when working with that data.
Mm,
If you are working on some social projects, that's different kind of data that can be handled in different way.
mm.
So these data centers and the way we are preserving the data, it's also taking a lot of energies, resources, and everything
Right.
to keep it safe and to process it in efficient manner.
So it's not just processing, and of course, the processing. There are companies like I think Extropic is a company which is trying to use some thermodynamic principles to create new AI chips. Great. I would like
Hmm.
to find out how that works. But you're also saying it's also the just the sheer amount of quantity which is available to somebody.
Yes,
Amazing
yes.
memory. Okay. Speaking of memory, then I ask a question too. I mean, I tend to use Grok more than ChatGPT, but I ask a question, and then I did that yesterday, and then I don't know what happened, but the screen went away. I had to ask the same question again, and a totally different answer came in. Now, how does that work? And how is that reliable? Because sometimes you want a certain aspect of reliability from a machine, right? So if I'm turning on my dishwasher, if I press that button, I need to know it's going to do the same thing. But here it's kind of has a mind of its own, which is probably sometimes annoying because I needed a specific answer. How do you tackle that problem?
Definitely, that's very big problem, Sagar. We call it hallucination, right?
Mm,
You will see like there is a lot of hype of these models. People are just posting about LLMs and everything. They do just basic kind of proof of concept with these new techniques, and they just write everything on the LinkedIn.
mm,
But when you will see actually in the companies, right, in the organizations, to take it or you can say to use that those models to production is something really very different,
mm,
because clients will ask you, how can I rely on this?
mm.
And we have no answers to it because it can hallucinate.
Okay.
So there are different ways to tackle with it. There are different mechanisms which are now being coming into the market, right? So one of the ways, I will just touch base upon it, RAGs, retrieval augmented generation, where not we are openly asking the LLMs, but we are giving them the relevant amount of information and then asking it to formulate the answer out of it.
Mm, mm,
So
mm,
when
mm.
we actually specify the things, then it gives us the good answers. But if
Okay.
I will just openly ask something, when this ChatGPT came, many companies integrated that to their chatbots.
Mm,
They seem like everything is very sorted. We can ask anything, and things will work like wonder. And
yeah.
now what's happening is, what kind of problems coming in the market? They want to replace ChatGPT with something else.
Right. Right.
That's the main problem now. So over there, now we are again using different techniques to guide it to generate the response. Definitely, it's having good generative capability,
Mm,
but again, generate from what?
right.
That's very important.
Right. Right. So there is a possibility where, let's say, we you want to make like a very good assistant professor which is a chatbot or whatever, and so everything ever printed in that domain, it's best if that particular model has that data in it. Like, how rich does the data need to be? How far back does the data need to go? And what happens when you're dealing with like older variations of English, or things that are not currently, like, we don't say thou and all that. So how is this like a linguistics problem? And that's why companies are trying to, get those experts and do some translations for them. How does that work?
See, what is happening is, when we actually train a child, right, about a language, we follow a certain pattern.
Okay.
We first let them know about the alphabets, or the basics. Then they start to form the words. Then we tell them the similar words. Then they make the sentences. So similarly, at that point of time, teacher is someone who is correcting them continuously
Hmm.
wherever they are going wrong.
Hmm.
So that same thing is happening with the model. They
Right.
gave it everything, but he actually doesn't know everything, right?
Yeah.
So we need someone to go along the way to correct it.
Right.
That's where human in the loop came.
Right.
And wherever it's turning around from, where it should be, the humans are correcting it, and those are the linguistic experts actually,
Those are the linguistic experts.
helping
Okay.
it to learn. Yeah,
All right.
yeah.
Now, what are reliability scores over here? I do remember, like in previous projects that we were together on, that this was a big sort of like hot button area. So, how, first of all, how do you um, set the criteria for what reliability is, and then how do you score it?
Yes, so for evaluation, Sagar, there are when we work with these, generative models or large language models, there are two things which we have to evaluate.
Hmm.
One is the capability of model to generate the response given the correct context to it.
Hmm.
Second thing is whether we are actually retrieving the right context.
Right.
It's very important.
Right.
So for those, we have certain matrices now
Hmm.
on basis of which we can actually evaluate it, and even ask those generative models again to give us the reason,
Hmm.
using those llms again as a judge, where first we generate the responses from them,
Hmm.
and then give them the ground truths and their generative responses, and ask them like how relevant it is.
Hmm.
So that way we are evaluating it.
Okay.
So based upon those different matrices, we actually look into both the aspects of it, like how we are retrieving the context and generating the answer for the end user.
Are these models, not machines, are these models learning primarily via induction, where they see a lot of concrete examples and then they figure out what the basic general principles are? Or do we give them the general principles and then they have to deduce what the concrete examples are?
So when we talk about the base models, right,
Hmm.
we give them everything,
Okay.
and they learn whatever they can learn out of it. But
Hmm.
when we use them for specific tasks, definitely we have to fine tune the term which I'm using, right, the fine tuning,
Hmm.
where we are giving them the specific examples, or even the term prompt engineering, giving them the clear instructions like,
Hmm.
okay, do this for me, do this for me, and then giving certain examples. There are different variants of it further.
Hmm.
So then we are refining them further.
Okay. I'm glad you mentioned prompt engineering. I was about to forget that question. How important of an art form do you think prompt engineering is going to become in the future, or not? Is this just going to be like a transition phase when the models are going to get perfect?
The prompt engineering is, even right now, many of the open source libraries which are getting built upon,
Hmm.
they are using these prompts at the back end.
Okay.
What is happening is these large language models are being trained and they are out in the market, right?
Right.
The open source ones.
Hmm.
Now, folks are building up the libraries where
Hmm.
they are writing the prompts,
Hmm.
where prompt is actually doing everything. And
Okay.
we saw it as, a library is there, just go, I use this library, get your work done. But if you look into the source code,
Yeah.
it's the prompt over there.
Okay.
Definitely there are some other aspects of building the library, but
Hmm.
backbone is the prompt, which is helping you to evaluate something, which is
Hmm.
helping you to generate something, which is helping you to structure something, right?
Hmm.
So they are very important and very crucial.
Okay. So this might be a good sort of field to keep investing in. Like a language degree helps if you want to like prompt something properly. Okay.
Yes, yes, definitely. Yeah.
Okay.
It's depending upon you. I mean, what, how much or you can say creative thing you can take out of it. It's
Hmm.
whole bunch world of ideas. It's again back to your skills, how much in a creative way you can ask it
Hmm.
and get something out of it.
And in the creative way here, are we, is this like speaking to a super logical individual where you can give them very precise instructions and they can come up with various things? Or is this like speaking to more creative types where they speak in metaphors and nothing is really pinpointed and they're just communicating feelings? So what's the gold standard for prompt engineering?
So there is no such kind of a thing. To
Okay.
be very frank, it's
Hmm.
depending upon again the use case.
The use case.
In data science domain, data, use case, algorithms, they are they vary upon from scenario to scenario.
Hmm.
If your use case is different, your approach will be different, right?
Hmm.
Your data will be different.
Hmm.
So when we are talking about the prompt engineering, now let's suppose you are a poet or
Hmm.
you are a writer.
Hmm.
So what you will be doing with those model is you will be giving them either some examples of your work, or you will telling them, okay, I want to follow this particular writer, try to put something in that tone, and after that put something in that tone, right?
Hmm.
So giving it those kind of instructions or prompts, and it will generate the content for you,
Right.
right? If it has gone through that whole bunch of data.
Hmm.
And similarly, if I am building something factual, right, where I'm checking the facts, right? So I want to have a precise answer. If I'm asking about a capital, then I don't want to model to say that sure, I can help you with this thing. The capitals are this, and So depending upon the use case and scenarios, you give different kind of instructions and you receive the required answers.
Right, right, right. I think let's see if it'll be able to like generate good comedy because the whole point of that is the word remains the same, the context shifts, right? So, and the
Yeah.
context is often unsaid. So I don't know how I don't know how they figure that out. Also, I don't know how they figure out the non-verbal communication aspects of it, the non-written communication aspects of it. But like, more power to them. Let's see. That's why
Yeah.
I guess they need all that compute.
Yeah.
I want to shift gears a little bit.
Yeah, sure.
Simpler topic, I suppose. Data analysis. How do you distinguish data analysis from ML or data science generally? Well, okay, data science is a broad term, but ML and AI and all these things. What is the narrow
Mhm.
scope of DA?
So yes, so we can segregate data analysis to some extent from machine learning.
Okay.
So when you say we are talking about machine learning, we
Hmm,
definitely do the data analysis, but
hmm,
in a bit of different aspects.
hmm.
So a pure data analyst will actually go through the data. It will bring it to in such a form so that we can actually make some plots out of it, or you
Lots.
can say some analysis out of it, right?
Right.
And for those purposes there are tools like Tableau, Power BI,
Right. Right. Right.
and we know, right? So those are being used to generate a dashboards kind of a thing, or a report which can actually give you an insights like, okay, we have this kind of data,
Hmm,
it's having all these xyz things inside it, right? In this much capacity, again a qualitative or a quantitative research, right? And based upon that, whole that bunch of report is given to the data scientist. Okay, so this is the data,
hmm.
this is something which comes out of it. We at initial stage we bought out of it. Now for solving that particular problem, how you have to transform and how to manipulate it, that's upon the data scientist.
So the data analyst analyzes and essentially figures out in form of a literal figure what the data is saying and if there are any
Yes.
trends or is just noise or whatever. And then
Hmm.
they give that polished data and analyzed data to data scientists for what? What do the data scientists do there?
So let's suppose now I am solving some problem and I'm
Hmm,
having some data, right?
hmm,
Now with that data, if I want to augment it, if I want to transform it to some other way, if
hmm,
I want to do feature engineering, right?
hmm,
Creating new feature out of some features, combining them, or removing some of the unwanted features.
hmm.
So all those kind of things that thing is being done by the data scientist.
Okay.
And
Okay.
even in small organization, what happen is this whole process of analyzing and then utilizing is being done by the data scientists only.
Right, right, right.
Yeah. So it's kind of that.
What is a data engineer in this respect? And also a data, you use one more term, data annotator, right?
Hmm, hmm,
So
hmm.
what do they do? Is this like even like let's just say less complex roles?
Yes, so if we talk about the data engineers, when we work upon the cloud platforms, right, when the data is so huge, and when we talk about the data lakes,
Hmm. Hmm.
not just a particular data source, right? So then working and processing that data and bringing it into some particular form so that it can be further utilized. Data engineers do that part. They actually engineer the data, right?
Okay.
And if I talk about the data annotators, they actually tag the data. When we talk about creating a training data for the model,
Right.
telling that let's take the example of the dog cat classifier.
Right.
So we were not having readily available data where it was being tagged that this is dog image or cat image. So data annotator, so over there is basically tagging that part for you.
Right. Right.
Or
Right.
data reviewer is once, you can say evaluators,
Right.
once the model is giving the output, matching it with the correct outputs we are getting, the ground truths and the generated outputs when we are matching them.
Perfect.
So that part, the evaluation thing, although we have matrices, but even
Right.
humans also do that part at some extent in some kind of problems.
Okay. So, in order to close out this episode, now, do you recommend any videos, courses, or books for people who are, let's say, not in the field or in allied fields, are first interested to see if they are a good fit for this particular field or not? So, what do they start with?
Yes, so to start with, Sagar, there are a whole bunch of things. You go to Coursera, there are many courses. You go to that part. Udemy or even other sites, right, which are available, which are providing you the courses. And even more than that, I will say you can start reading the blogs, which will give you a basic idea about those things, whether you are getting even fascinated with that part or not.
Hmm.
And after that, either taking some specializations or first practicing that part, utilizing the Kaggle platform. So there are many things which can be utilized in order
Any,
to.
sorry, go ahead.
So it basically depends upon your preference. Some are, who prefer books.
Hmm.
They can go with some books being published regarding, getting deep dive into. Let's suppose we talk about the large language models, right?
Hmm.
So if you are interested in that part and you are someone from this domain, then you will go with some books or some good references like the
Hmm.
deep learning AI, right? They are giving a lot of courses on this LLM thing, so you can refer that part. And if you're someone coming from, let's suppose, software development background,
Hmm.
you know how to code, you know everything, but you want to learn about machine learning algorithms,
Hmm.
you can refer to the courses of Andrew Ng. There are some other folks like JLMR if you're going into the NLP stuff. So there are certain personalities, or you can say icons, which have actually contributed some good amount of work to the community. You can refer to that work. And once you have a basic idea by watching either YouTube videos or going through all those things, you can then make up your mind and take some specialization from the Coursera, right?
Hmm.
And more about this thing is like, more you practice, actually, more you get your hands dirty, more you will be confident, and you will able to strongly build your will that you either want to go into this domain or not.
Okay.
So
Perfect. So, Andrew NJ, I obviously heard that name before. So, I think he has a big Coursera course, right?
yes, and now the deep learning AI is being run by him, and a lot of courses are coming over there. You can utilize them to get into this domain.
Perfect. So, what else? I mean, what are your projects in the future? Are you also mentoring and training others? And how do people reach out to you?
Yes, so definitely, I mean, in order to reach out to me, my LinkedIn is there. You can reach out to me over there. And if I talk about my future projects, I want to explore more and more about this domain. So
Okay.
earlier, I was doing some corporate level projects. Now, I recently got a chance to work for the social innovation project,
Hmm.
where I'm working with the Ontario government, Humber College, and we are working upon finding the employability gap
Hmm.
between the international graduates and the Canadian job market, right? So, so these are different aspects. So the things which we are doing over there is totally different from what we do in the corporate, right?
Right.
So as I'm working as a consultant as well, so there are different roles and responsibilities over there. Even I will be publishing a book in some time, working upon that part,
Hmm.
and obviously research papers and all those things. And apart from that, I'm continuously writing the blogs, which is actually keeping me in touch with new topics and everything, and interacting with the community. So it's a whole a lot of things you have to do in order to remain active in this community. So it's growing at very fast pace. And in order to reach out to me again, I will repeat that LinkedIn is a good source, and even you can mention my email if someone wants to talk about something specifically below in the description. Yeah.
I'll definitely include your LinkedIn in the description. And tell me this. So, are you at liberty to talk about what kind of book you're writing at the moment, or that's going to be for later
Majorly, it will be on the LLMs.
on LLMs? Okay,
Yeah.
perfect. So, is like for specialists or for the general market?
We'll go level by level.
Level by level. Okay, great. I'm going to buy that. Like, I'm
Yeah,
pre-ordering.
sure.
All right,
Thank
perfect.
you. Thank you so much. Yeah.
Awesome. Well, thank you for
Thank you.
coming on, Bavel. Do you have any last words?
Last words are like, I mean, it was really great, interacting and talking about this topic. And whenever I talk about the data science, I feel so fascinated. And you might also have observed this thing, like it's like I start speaking and then I speak and speak and speak. So
Yeah.
I really enjoyed it. And
Awesome.
thanks a lot for the opportunity.
And thank you for coming in. All right, folks. See
Yeah,
you around.
welcome.